This has probably been the most useful project I've ever worked on. Not because it changed the way people study, but because it completely changed the way I approach building hardware projects. And after months of prototypes, failed ideas, terrible audio setups, and way too many debugging sessions, this is the final result. At some point, I realized I was getting completely bored of my normal study routine. Every day felt exactly the same. So I started wondering if I could build a completely different way of using Anki with an ESP32. Something minimal, no screen, just audio, physical controls, and eventually a few extra features to make studying feel less tied to a phone or a PC. And looking back at it now, I would say the first goal was achieved. The second one, not really. But we'll get to that later. The date is not random. At that time, I had just started my first year of computer engineering here in Italy. And because of that, I knew I couldn't keep making the same kind of fast-paced summer projects. So instead of building a completely new project every week, I decided to slowly document one bigger project over time. And honestly, that decision completely changed the way I make videos. Before touching the hardware, I had one important question. Does Anki even have an API? Because if the answer was no, this project would immediately become way more complicated. Luckily, there already was a REST API available, and that completely changed the direction of the project. At first, I didn't fully realize how useful that API would become later on, but looking back now, it probably saved the entire project. So the first prototype was extremely simple. I was basically sending flashcards directly from the VS Code terminal. Once the API worked, it was time for the easy part. The kind of setup you already know how to build because you have done similar things before. The ESP32 connected to the same Wi-Fi network as my computer, downloaded the flashcards over HTTP, and handled the study session directly from the serial monitor. And technically, this already worked. The ESP32 could receive the cards, generate a study session, and handle everything directly from the serial monitor. And this is where the fun part started. Because the moment I added audio, the project immediately became much more unpredictable. The entire idea depended on being able to listen to the flashcards comfortably. So I started experimenting. I ordered a couple of audio modules from AliExpress, tested different speakers, and honestly, most of them didn't work. Eventually, I settled on a very questionable PWM setup. It definitely wasn't good. But for the first prototype, it was enough to prove the idea. At this point, the project was finally starting to feel real, which is exactly when the storage problems started. I was convinced that a micro SD card would be the perfect solution for this project. Instead, it became a complete nightmare. Downloads kept failing, the setup was unreliable, and every time I thought I had fixed the issue, something broke again. And the worst part was that I didn't even know what the alternative was. That single problem slowed down the entire project for almost 2 months. After weeks of trying to fix the SD card setup, I eventually realized the problem wasn't just my code. The entire storage approach was wrong. So I started looking for alternatives, and that decision eventually pushed me to switch the whole project to ESP-IDF, just to properly work with an external flash memory, alongside the internal flash of the ESP32C3. It was painful, but it completely changed the reliability of the device. Once the storage finally worked, I could focus on improving the actual experience of using the device. And the first thing that had to go was the old audio setup. So I replaced the speaker system with a proper audio jack for headphones and started testing different modules. Compared to the storage disaster, this part was actually pretty straightforward. But the difference in audio quality completely changed the feel of the project. At this point, the project was finally working the way I wanted. The storage was reliable, the audio setup worked, there was only one thing left, turning this into an actual PCB. And honestly, this was probably the most intimidating part of the entire project. Because once you order a PCB, everything has to work. So instead of immediately designing the final board, I decided to split the project into smaller PCBs first. One for the audio setup and one for the ESP setup. I wanted to make absolutely sure every subsystem worked before committing to the final version. And finally, when those first test boards finally worked on the breadboard, I knew that the final PCB had a real chance of succeeding. And so I started designing the entire PCB on KiCad. And by the way, I want to thank all the people on Reddit that decided to comment under my review request on Reddit. And after that, it was time to get the board manufactured. Usually this is the part where I would spend hours soldering all the components onto the PCB myself. But not this time. For this project I used PCBWay for both PCB manufacturing and assembly, so the boards arrived fully assembled and ready to test. Honestly, the quality came out great. The boards look super clean and all the components were perfectly placed. And everything worked right away. Uploading the Gerber files and ordering was actually really simple. You can customize the board specs, choose assembly options and preview everything before placing the order. I even made a video about the PCB assembly service, so check this out. If you are working on your own electronics projects, prototypes or even small production runs, definitely check them out. Huge thanks to PCBWay for sponsoring this build, and go check the PCBWay link in the description. Now that you know how I built this project, how does this thing actually work? Instead of starting a normal Anki session on your phone or your computer, you open Anki on your computer, start the local Flask HTTP server written in Python that you can find on GitHub, and turn on the device. Once the ESP32 on the device connects to the server, it downloads all the audio files for the flashcards due today. And after that, the study session starts. The device reads the front of the card through the headphones. You can replay the audio whenever you want using one of the 3 buttons, and then reveal the answer. And at that point, you can rate the card exactly like in Anki. Instead of having 4 buttons like in Anki, you just have the Again button and the Easy button. And once all the cards are completed, the ESP32 on the device sends the results back to the computer, which automatically updates your Anki profile with the results. This device is obviously nowhere near to replace the Anki experience on a phone or a computer, but honestly, that was never really the point. The point was learning how to actually build a project like this from start to finish. How to deal with hardware problems, long debugging sessions, redesigns, datasheets, mistakes. And honestly, this project taught me more than most of the projects I've ever done. Not because it was the biggest one, but because I stayed with it long enough to actually finish. And I still think this kind of device could become something generally useful one day, not necessarily as a replacement for a phone or a PC, but as a completely different way of interacting with the study session. There are still a lot of features I would like to explore in the future, but those are considerations for another video. And now, I think it's finally time to start the next project. Lately, I've been watching a lot of EMG projects, and I kinda want to build something with that. So subscribe if you don't want to miss out the next big project. If you want to know more about the code and how it works in the details, you can check the last recap episode of the series, or you can go here on my website, or you can check also the GitHub link to see all the code. Thanks for watching and thanks to PCBWay for sponsoring this project.